Alright, today we're looking at Chapter 10, Lesson 1, which is Area of Parallelograms. We're going to be figuring out how you can find the area of parallelograms. Our learning objective is you will find the area of a parallelogram or square and find an unknown measurement for a parallelogram. The area of a figure is the measure of the number of unit squares needed to cover it without any gaps or overlaps. The area of a rectangle is the product of the length and the width. The rectangle shown has an area of 12 square units, so this right over here has an area of 12 square units. And for a rectangle, the length, or L, and the width, W, we will see that formula written as A equals L times W, or area equals length times width. Recall that a rectangle is a special type of parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. And again, those parallel sides mean that they would go and go and go and never touch. So the top and the bottom of that parallelogram over there would be the parallel lines or the two sides. So let's look at unlocking the problem. Victoria is making a quilt. She's using material in the shape of parallelograms to form the pattern. The base of each parallelogram measures 9 centimeters and the height measures 4 centimeters. What is the area of each parallelogram? So you're going to draw the parallelogram on grid paper and you're going to cut it out. For video purposes, I'm not going to cut it out because you wouldn't be able to see it. So I'm going to draw it on this grid paper instead. So here I've drawn 9 centimeters at the bottom, so you can see that covers 9 unit squares on the bottom. And then the height is 4, so I went up 4 and drew another 9 lengthwise. Okay, so you can see I have a length and a height. Length of 9 and a height of 4. Okay, so you're going to cut along the dotted line to remove the triangle. So instead of me cutting along the dotted line, I am just going to erase along that dotted line. Okay, so the dotted line is still here. And I'm going to add that. So I'm going to add that over here. So I've added that. Okay, so I added that over here on the other side, which now you can see my shape kind of looks like a rectangle. Okay? So now that we've moved that from one side to the other, now it's an easier problem to solve. So let's look at this. So what is the area of our new rectangle, which where it shows it in this image for us right here. And we have the length of 4, and now we have a width, or a length of 9 and a width of 4. So instead of a height, we now have a width. So we know that length times width equals area. So the area of a rectangle was 4 times 4 times. Okay, I was having some computer malfunctions, so I've just switched over to new again. So, what is the area of the rectangle? We've said that that is 4 times 9, which equals 36. Okay, and that is 36 centimeters squared. So what is the area of the parallelogram? Well, we just switched that triangle from one side over here to the other. So the area is the same for the parallelogram, which is still going to be 36 square centimeters or centimeters squared. You can write either way. So the base of the parallelogram, that base is that length, okay? That is going to be the same. The base and the length are the same thing. So the base of the parallelogram is the length. of the rectangle. The height, that height of the parallelogram, even though it was the height here, it's the same thing over here, which is just going to turn into the width of a rectangle. So the area of a parallelogram is equal to the area of a rectangle. So just note that the base of a parallelogram is the same thing as the length of a rectangle. The height of a parallelogram is the same thing as the width of a rectangle, and the area of a parallelogram is the same thing as the area of a triangle. So for a parallelogram with base B and height H, A equals B times H, or you could write it as just B next to the H, so that means multiplied by. So the area of a parallelogram equals B times H, base times height, equals 9 centimeters times 4 centimeters, which equals 36 square centimeters. So the area of each parallelogram is 36 square centimeters. So let's go ahead and look at example 1. For example 1, use the formula A equals B times H to find the area. So we're going to write the formula. Okay, go ahead and write that every single time so you really remember what you're working with. So area equals base times height. Replace the B and the H with their values. So area equals 3.6 meters times, and let's look at the height right here, which is 2.1 meters. And then you're going to multiply. So you're just going to go ahead and multiply 3.6 multiplied by 2.1, which gives you 13 and 23 hundredths. Okay, so then your area of a parallelogram is 13 and 23 square meters. Okay, and let's go ahead and look at example 2. We're going to find the area of a square with sides measuring 9.5 centimeters, or 9 and 5/10 centimeters. So first you're going to start out writing that formula. And when it's going to be a square, you know that the length and the width are going to be the same. Okay, so you could write it as area equals S squared, which means both sides squared. So if you remember that writing something squared means a number times itself. So in this case, we would take 9.5 squared, which is the same thing as 9.5 times 9.5. Okay, and if we do that math over here, 5 times 5 is 25, to 9 times 5 is 45, plus 2 is 47. That's a 0 to keep our place values the same. 9 times 5 is 45. 9 times 9 is 1, plus 4 is 5. Decimal places in here, so we're going to move that over 2, which gives us 90 and 25 hundredths. So our area of the square is 90 and 25 centimeters squared. Please, please, please do not forget that label. It is so important that you put in that centimeters squared. And moving on to example 3. A parallelogram has an area of 98 square feet and a base of 14 square feet. What is the height of a parallelogram? So we're trying to find something that's a little bit different here. We're going to grab a different color so it's going to see the difference in the work. Okay, so a parallelogram, since we know different information than normal. We still need to write out that formula. Please do not forget. Write that formula there every time. And we're going to replace the A and the B this time instead. So we know that the area is 98. And we know that the base is 14. What we don't know is that height. So we're going to write that equation out just the same and replace what we know. So we're going to use the division property of equality to figure this out. So we know that 98 divided by 14 will equal 14 times h, because if it's 14 times h equals 98, then we can divide that out. So we're going to divide both of them by 14, which will then give us 7, because 98 divided by 14 is 7, and that gets rid of that 14 over here, so we just have h. So then we know that the height of that parallelogram is 7. Okay, last thing we're going to talk about today is how would you explain the difference between the height of a rectangle and the height of a parallelogram? The height of a rectangle is the width of one side of that rectangle. So, let's see. So, height of rectangle is simply the length of one side. But then if you think of the height of that parallelogram, if you look back at, let's see, that was on our Unlock the Problem. The height of the parallelogram was that is the length of the perpendicular line segment that was drawn there. It wasn't a concrete line. It wasn't exactly there. It's just what we knew was there. So it's the length of the perpendicular line segment drawn. From the base to the opposite side. And just a reminder of what that perpendicular means is it's intersecting with a right angle. So in just a second, I will go back to number 1 to kind of remind this. So here, the difference between the height of the rectangle, right here, the height of the rectangle was that width. So you can see that that is just the length of the side. So right here, that's just the length of the side. It is what it is. But when you look over here at the parallelogram, that height isn't actually there. You just know what it is because of the perpendicular line that we've drawn there from the base to the top. You know how high it goes. So it's just a little less concrete. And that is all for chapter 10.